Hello everyone, my name is Matt, also known as UKAstroNut, and today I'm just going to ask you one of those really long questions that humans and especially children have been asking for hundreds and hundreds of years, and we never understand what the answer is. We don't really know. We just try and blag it off and pretend that we know what it is, or just say, oh, ask your school teacher or something. But I'm going to try and explaining why is the sky blue? And it's not that hard an idea, but I suppose we don't really get taught it in school very much. And as I said, loads of people ask it and always wonder why the sky's blue. So I thought it's maybe quite interesting trying to explain it to you. So first things first, when you look up at the sun, the light from the sun looks white. So you look at the sun, okay, maybe it looks a little bit yellow or whatever colour, but the light from the sun coming down is white light. It's white because it's a combination of all the colours of the rainbow. So if you get paint and you mix all the colours of paint together, so you mix yellow, blue, red, green, purple, all the colours in equal proportions, you get a lovely colour of brown. So it doesn't work with paint, but if you imagine doing the exact same thing with light, instead of it appearing brown, the light appears white. So if you can split up the light from the sun into the individual colours, what you'd find is you'd have a rainbow. So this is basically how a rainbow works. Or even easier, have you ever seen a prism when you shine light through a prism? Or you've seen the Pink Floyd album, Dark Side of the Moon, which has the glass prism, and they fire a beam of light in, and it spreads out into all the different colours of the rainbow. So red to orange, yellow, green, blue, purple, so on and so forth. And it splits out all of these different colours, because the white light is made of all these colours, and a prism just basically splits out the light, depending on the frequency or the energy of the light. So the more energetic the light, the more it bends away from its original path. So you have a normal beam of light coming through a prism, and the red light will go almost straight through the prism and come out the other side, almost in the direction it's travelling. Whereas blue light, which is more energetic, gets deflected down more, so there's a bigger deflection as it goes through the glass, because blue light is more energetic. So this is the big thing you need to know, is that blue light scatters more than red light, i.e. it deflects more at a greater angle. Now, when light from our sun comes down to the Earth, it goes through our atmosphere. In our atmosphere, there are billions and trillions of gas particles, right? And what you have to imagine is that each of these gas particles is kind of like a prism. This is kind of the easiest way to think about it. So the light from the sun comes down, and it comes down as white light, but this white light is made of beams of red, yellow, orange, green, purple, blue, all the different colours, okay? Now, the red light comes straight down from the sun, and it'll hit the Earth. And it'll, actually the only red light's coming down, as you're stood underneath the sun, when it's straight above you, will be the red light coming straight down, okay? If you look to the sides, you're not going to see any of the red light, because it's going to come down at an angle, and the angle is never going to reach you, because it's always going to be not going near you. The only red light is going to be coming straight down from the sun. Now, if all the gas particles are kind of like prisms, then the prisms will take in some of the red light, and some of them, it will deflect slightly. So some of the light that's coming slightly not near you might hit a gas particle down here, and it might just deflect down and hit you. So if you look slightly to the left or slightly to the right of the sun, you might also see the sky can be a little bit red, okay? Or some of the other colours as well. But what happens with blue light is that the blue light you see, when it comes straight down from the sun above you, you can see the blue light. But when the blue light comes down at a really large angle, so it's not going to go anywhere near you, okay, it's going to miss you by a long distance. What can happen is it can hit a gas particle out here, and it can be scattered, deflected by this gas particle, like it does in a prism, with a really large angle, and it can come all the way down to hit you like this. So what this means is that if you're looking at the entire sky as a whole, as you're looking at all the gas particles in our atmosphere, all of these can be deflecting at really large angles, so that whatever direction you look up in the sky, chances are you're going to be looking at a blue beam of light that's been deflected and scattered by a gas particle, so it fires straight down towards you. So only when you look up at the sun do you see the blue light, but also when you look really far away and right towards the sides of the sun, really large distances away from the sun, large angles, you'll still be seeing the blue light that's been scattered by gas particles. Now this doesn't happen, as I said, because red light doesn't scatter very much. So when you look at the horizon when the sun is above you, you'll see a lot of blue light because it's scattered at that large angle to get to you, but the red light can't scatter that much, and so when you see the red light, it's basically coming straight from above you. Now, this is also kind of why if you look straight up in the sky, it looks very blue, but if you look at the horizon, it looks a slightly more white, a slightly less coloured blue, and this is just because the blue particles, even they have so much that they can scatter, and so if you look at the horizon, they're less likely to scatter this very large angle here compared to a small angle. And so when you look at the horizon, actually the horizon looks less blue than it does if you look straight up in the sky. This is also kind of explains why sunsets are red, and this is because as the sun, if we look at the sun when it's on the horizon, the sunlight comes straight through to us, so it just comes straight along the land, along the horizon, and the red light comes through like this. When blue light comes through, it'll come through here and it'll just scatter off into random directions, and so not very much of it will actually reach us. And so that's why at night time, well, at the sort of dusk, twilight, sunset, sunrise, the sky looks more red and yellow because the light's coming straight through and the blue light scattered upwards and towards the ground and stuff, but the red light comes straight through to our eyes. So that's why the sky is blue. The sky is blue because blue light is more energetic than red, and the blue light particles can be scattered from anywhere in the sky. So wherever you look in the sky, chances are you're looking at a blue particle, a blue beam of light that's been scattered by a gas particle, whereas the red light doesn't scatter that much, so it only looks red when we look straight up at the sun. So thank you very much for watching. Hope this kind of explains why the sky is blue. Hopefully you can try and explain it to someone else. Thank you very much for watching. If you have any other questions like this, things you want to know, any sort of problems in physics or anything, or astrophysics that you want to know, just leave me a comment and I'll try and answer them for you. But if not, don't forget to like, click the subscribe button, tell everyone about my channel if you can. I'd really appreciate it. Thank you very much for watching, and I'll see you guys soon.